Alright guys, it's time for part 2 of atomic bonding. The name is bond, covalent bond. Alright, so we learned about ionic bonds, and you remember that's when electrons are actually given and taken. So now we're going to talk about the only other possibility for atoms to bond, and that's if they go ahead and share. Isn't that nice? Covalent bonding sounds much nicer. Okay, let's take a look here. The classic example, and the easiest one to look at here, is between oxygen and hydrogen. Let's take a look. So if I'm oxygen, oxygen is number 8. Good. So I'm going to go ahead and say, there's the element symbol. The first energy level has 2. Okay. And then I can put 8 in the second energy level, but oxygen only has 8 electrons. So 2, 3, 4, 5, 6, 7, 8. Notice that in order to have a full energy level, there are 2 spots that it could fill right on the side there. Well, fortunately for oxygen, we'll go orange for hydrogen. If I have a hydrogen here, hydrogen is element number 1, and so it has 1 electron in its outer energy level. Boy, would it like to have another one? Sure it would, because then it would have a complete first energy level. And if I bring another hydrogen down here, like this, it's also got 1 electron. So here's the deal. Hydrogens walk up to oxygen and say, hey, buddy, here, can we work a deal out? Can we work a deal? Let's talk about this. You've got 2 spots in your outer energy level that you'd love to have filled with a couple of electrons. We would love to have an additional electron. I bet we can work a deal here. Let's do this. If we go ahead, all right, and we share our electron with you, and you share one of your electrons with us, all right, what we can do is we can all be happy. How about that? And oxygen thinks about it, says, I don't know. But pretty soon oxygen agrees and says, yeah, that sounds like a good idea. So check it out. I'm going to use red. If you take these electrons here and take these electrons here, let's count them up now. Anything inside the red circle, let's say, is you can count them for both atoms. So let's count up oxygen's second energy level. Remember, the second energy level, I'm going to write it in blue, the first energy level has 2 electrons max. The second wants to have 8. So let's count them up. Oxygen has, in the second energy level, 1, 2, 3, 4, 5, 6, and then you got to count this one, 7, and this one, 8. All right. By sharing with 2 hydrogens, oxygen gets 8 electrons in its level. Now let's look at hydrogen. I'll count up hydrogen's electrons with green. Okay. Hydrogen would like 2. Let's go to the bottom hydrogen here. I get 1 here. Oops. How's that working there? Okay, there we go. Good. I get 1 electron here, and then 1 electron here. Perfect. The one on the top, same thing. 1 electron there, and 1 electron there. Perfect. Hydrogen gets 2, and it fills up its energy levels. I'm going to go to the next screen, and here's what it would actually look like. Let's draw them in purple just for fun. Here's oxygen, and energy level 1, 2 electrons. Energy level 2, and I'm going to draw this a little bit differently. 2 electrons here, 2, 4, and I'm going to put 5 and 6, and then I'm going to change the color, and we'll go to red. Okay, to represent hydrogen, here's hydrogen, and here's its only energy level there, okay, and hydrogen, here's its energy level here, it's got that 1 electron, and these guys are being shared, all right? So these guys are being shared here, these guys are being shared here, and by doing that, oxygen is able to form bonds with 2 hydrogens, not just 1. And in this case, if a hydrogen gives up its electron, it doesn't have any electrons, so that's not a good, even though oxygen would happily accept them, that doesn't leave hydrogen in a good place. So hydrogen really doesn't want to do that. And since oxygen already wants electrons, hydrogen's not going to take an electron from oxygen, because oxygen doesn't want to give it up. So the only thing that really makes sense between these 2 elements is that they end up sharing them. They say, all right, well, then we got sharing. And if you want to draw it, water looks like this. And there's a little bent. There's kind of a big angle right there. They're kind of bent like that. But the point is that you get the sharing, and because oxygen shares with 2 hydrogens, oxygen gets 8 electrons in its second energy level, hydrogen gets 2 in its first energy level, and everybody is happy. All right? So what does this mean in terms of the trend? All right, so here are the trends that we need to follow. Sorry, I think things got cut off there for a second. All right. So, if, number 1, let's make this a little bit thicker on the pen here. Metal plus non-metal equals ionic. Okay, example, lithium chloride. Okay, you got someone from the very extreme left-hand side and the very extreme right-hand side, because metals usually like to give up electrons and non-metals like to get them. So you don't want to share, you want to give it and you want to get it, so this is an ionic situation. 2, we have non-metal plus non-metal is going to be covalent. Because both, when you're a non-metal, again, you like to get electrons. So if you have 2 people getting together and they both want electrons, the only way they're going to be happy is if they end up sharing them. Okay, example, H2O that we just did. Hydrogen and oxygen like to share electrons. Okay, now what about the metalloids? Metalloids. Okay, well, it depends. Again, you should probably figure that, since they kind of share characteristics of both metals and nonmetals. It depends on who metalloids are getting together with. If they're getting together with nonmetals or metals, or how far apart on the periodic table they are. Don't worry too much about those. But these are the trends you need to know. And someone else is going to ask, well, what happens if 2 metals get together? Okay, well, they don't bond ionically or covalently. So metal plus metal is going to equal something we call an alloy. And don't worry about it, you just need to know the word, okay? Essentially what it is these atoms of metals all start swimming together in this one giant lump of metal and sharing all their electrons. It's a very, very separate type of thing, and it's not a traditional bond as you would think it would be, okay? So you won't need to know the chemistry of alloys, and you don't need to know the detailed chemistry of metalloids. But you definitely should be aware, okay, that ionic bonds happen between metals and nonmetals, and covalent bonds happen between 2 nonmetals, all right? So those are the trends that we're going to look at. So depending on where these elements come from on the periodic table, this will tell you what kind of bonds they're going to form.